three coins are tossed, which of the following statement is not true? So here we have a question. First of all, we need to find out how many total outcomes are possible. So the total number of outcomes in case of coins can be calculated in this way. The total outcomes will be equal to, we have three coins and every coin has two outcomes because one coin can give us either the outcome head or tail. So the first coin will have two possible outcomes, the second coin will also have two possible outcomes, and the third coin will also have two possible outcomes. So in that way we have 8 total outcomes. If you want me to write those things manually, I can do that because we are just starting off with the very first question here of probability. So if I were to write all the outcomes, I would probably pick first of all two coins. With two coins, the outcomes possible are head head, head tail, tail head, tail tail. If there is a third coin, then the third coin can either result in head, so that's what I'm writing in the beginning, or the third coin can result in tail. I'm writing that once again 4 times and I'm repeating these 4 cases once again. So I have head head, head tail head, and tail tail. So this way we have 8 outcomes. It's a question which is quite simple to answer because even if you are able to write all these outcomes manually, you can answer these questions comfortably. I'll keep telling you how to do that. Let's look at the very first question. The probability of getting at least one head. So there should be minimum one head. At least means minimum. That means either there should be one head or two head or three heads. So one thing that you can do is you can manually count. The first one is yes, the second one is yes, third one is yes, fourth one is yes, because we can see at least one H written here. Fifth one is also yes because we have two heads here. Sixth one is also yes because we have one H here. Seventh one is also. Eighth one is not. So we have 7 choices, so 7 out of 8. So this has to be true. Alternatively, if we were to calculate this mathematically, so at least one head means there are possibilities that either there should be exactly one head, or exactly 2 heads, or exactly 3 heads. Exactly one head out of 3 can be calculated in 3C1 ways, which is 3. 2 heads out of 3 coins can be calculated in 3C2 ways because out of 3 places we want 2 places to be filled with H. So we select those 2 places in 3C2 ways and there is only one way to arrange them because both the H are identical. So once again 3 and all the 3H, which means 3C3, that's also equal to 1. So the total outcomes will be 3 plus 3 plus 1, that is 7. So the required probability in that case will be equal to 7 divided by 8. This is number 1. So it seems that it is true. So obviously it is out because the question is specifically asking us the case which is not true. Now let's quickly look at the second B. Now B says the probability of getting at most one head. So let me write at most means maximum. I'm going here slightly slower for the students who are just starting it off. Therefore, I'm not jumping any steps. So please pay attention to all these things. Now I am checking option B. So option B says at most one head. I've already written it is maximum one head. That means either we can have 0 head or we can have exactly one head. One head can be calculated in 3C1 ways like we have done it in the previous case as well, and 0 head can be calculated in 3C0 ways. 0 head anyways means all the 3 should be tails, so that is possible only in one way. 3C1 gives us 3, so sum of them gives us 1 plus 3, that is 4. So the required probability becomes 4 over 8, which is 1 over 2, and the option also says it is 1 over 2, so that looks like again it is true. Anyway, you can manually look at it. We are looking for the cases in which there is a maximum one head. So the first case is out because we have 3 heads. The second case is out because we have 2 heads. The third case is out because we have 2 heads. Fourth case is yes. Fifth case is out, 2 heads. Sixth case is yes because there is only one head. Seventh case is also yes because there is only one head. Eighth case is also yes because there is no head. So 1, 2, 3, 4, 4 yeses. So that way we could also have done it manually by writing all these arrangements. So it is also true. Now let's go for C option and see how to see the C option here. So the C option says The probability of getting exactly 2 heads. Now that's slightly easier because there are less cases here to calculate. Exactly 2 heads. That means there should be only 2 heads. So out of 3 cases, out of 3 places, we want 2 places to be filled by H. So 3C2, that means 3 cases. So in that case, the required probability should be 3 over 8. Let us see. Yes, the option also says that it is 3 over 8. So that is definitely true. Alternatively, you could have found, even looking at these cases, that first case is a no, the second case is yes, the third case is yes. We are looking for exactly 2 heads. Fourth case is a no, fifth case is yes, sixth case is a no, 1 head, seventh case is a no, 1 head, eighth case is no, 2 heads. So we have 3 yeses. In that way, the third case is also true, so that also is out. Now, let's look at the next possible case, which is option D. Option D says probability of getting at most 3 heads. So, at most 3 heads, that means maximum 3 heads. So we have to consider the case of 0 head, we have to consider the case of 1 head, we have to consider the case of 2 heads, as well as we have to consider the case of 3 heads. Now the question to think is there any possibility that we get more than 3 heads? Then the answer is strictly no. The reason is we have only 3 coins, so the maximum number of heads that we can get is 3 only. So basically all the 4 cases combined, we already know that we are considering all possible cases. If you want to calculate it mathematically, which we should never do, and it should be 3C0 plus 3C1 plus 3C2 plus 3C3, and if you add them all, the sum of them comes out to be 8, so the required probability becomes 8 over 8, that is 1, because 100% chances are that there will be at most 3 heads. So this is definitely false, and therefore this has to be the correct option for this question, because we were looking for the option that had to be false. Anyway, you can see that all the cases are yes, because we have at most 3 heads. So in all the cases we have maximum 3 heads, 3 or less heads. Now, just for sake of our understanding, I am also solving this another one, which is option E. That's only for sake of our understanding. Let's quickly see. E option says that probability of getting exactly 3 heads. Exactly 3 heads is only this one case. So the probability should be 1 over 8. So it's anyways true. And mathematically, E option could have been calculated exactly 3 heads. That means we have to say 3C3. That means only one way. So the required probability becomes 1 over 8. So that means this also is true. There is a previous case, we have already seen that it was false. Now we have our answer, that is option D. Thank you so much for watching this video. The idea was only to explain it in as much detail as possible so that every student who is starting it off can understand that how the calculations have to be done. Thank you so much for watching this video.